All right, good morning, everyone. Let's get started with today's class. So today is a topic that I decided to incorporate into the topics that we cover this year, because I noticed last year, I guess I assumed that people were familiar with this already, and I don't think it was the case for everyone. So just to make sure that we're all on the same page, I want to show you, we're going to be doing digitizing today. So basically, if you've done that before, it's basically just creating some type of geospatial vector data in a GIS, right? So let's say you're creating a field boundary, or maybe you're creating points that you want to sample, or maybe you're creating a line that represents a river that goes through your property, whatever that is basically digitizing. So you're looking at a map and then drawing on it, and then whatever that it is that vector file that we're creating. We're going to be using that for analysis down the road. So I did upload some files to our GitHub repo last night that I want you to, so the first thing I want you to do is to go to GitHub and retrieve those files. Again, if you're taking my other class, you may do a git pull if you have already forked and cloned that repo. If you're not taking my other class, you probably don't know what I'm talking about. You can just keep doing the way that you were doing as far as downloading manually from GitHub and then moving that into your main folder of the course. There's going to be a new script there that inside the 04 class code folder that's called digitizing. So that's what I want us to pull today. Once you download that from GitHub, so every time, and I hope you're going to start realizing that we have this way of working with different exercises is, so you download that from GitHub, and of course, I don't want you to be working with that file from the GitHub folder in your computer. I want you to actually create a different project in your class main folder and do all that setup as far as creating a folder. In this case here, I want you to call that 05 digitizing. That's what we're going to be calling this in your computer. So right now I am in the main folder of the class. And so I want you to create a 04 digitizing. Inside of that folder, I want you to create the code, data, and output subfolders. And once you do that, I want you to go to any RStudio window and create a new RStudio project at the level of this folder here. Just going to give you a second here to do that. So I'm just going to narrate again what I want you to do. If you're already working on it, great. If you got lost, I'm just going to go ahead and tell you again. So first, download or pull from the GitHub repo for the course, because I have a new script there for you. Then on your course main folder, I want you to create the 05 digitizing folder. That's going to be the exercise for today. You go inside the 05 digitizing, you create the folders code, data, and output. After you create those folders, you go to any RStudio window. I'm just opening one of them up here just so we can take a look at that. You open any RStudio window, regardless if you are already in a project or not. In my case here, it's showing that I'm not in any specific project. So I would just click on that top right button there and click on new project. Remember, we're always creating the folder structure before creating the project, meaning that we're always going to use this existing directory option, at least for this class. And then you just browse here to wherever that 05 digitizing folder is in your computer. And then you stop at the level where you can see code, data, and output, right? So we do not want to create the projects inside data or code or output. It needs to be at the same level of those. And once you're there, you click open and then create new project or create project. That's going to launch that RStudio window for you. So that is basically us setting up the exercise folder structure. And then I want you to go back to the folder or the repo that you downloaded, the files you downloaded from the class repo. And then inside of 04 class code, there's going to be a 0202 digitizing partial. That's what I want you to copy. And then go back to the 05 digitizing and paste that inside of code. So I just want to say here that, this is already the fifth exercise that we do in this class. Every time we do a new exercise, I will tell you, hey, go ahead and create the folder 06, whatever, and then move the files from GitHub to this, right? So I'm going to start. So right now we're still kind of walking through step by step just to make sure that you're getting used to this way of setting up your folders and files. But there's going to be a time that I'm just going to say, hey, I have some files on GitHub. Go ahead and create this main folder here. And then you should already be thinking, okay, so I'm going to create the 06 whatever, but now I know that I have to have a code data output and create a new RStudio project at that level. So that's going to be implied there because we're always going to do this process here. All right, so if we go ahead and if it's not yet on your side, please go ahead and launch that project, the RStudio project. So you should be seeing 05 digitizing on the top right as the name of the project. If you click on the R blue button here to take you to the main folder of the project, you can click on the folder code and you can launch that digitizing partial script, and that would show up on the left side there where we have the script. Okay, yeah.
So what's the difference in opening it that way and just clicking on the file like in my file?
Yeah, so that's a good, so Doug is asking what's the difference of doing this way or just clicking on that file? So if you, what I want to, I guess, propose that you always do is always click on that R project file first to make sure that you're launching your RStudio environment with the focus on that specific folder structure for that project. So by doing that, you could know you're in the right project by looking on the top right. If you come here and click on the R blue button to take it to the home of this project, here's what it's going to show you, right? And I do think that if the script is not popped up there yet, it's probably better to just browse here in RStudio and launch it, because then you make sure that you're launching the right file in the right folder, everything is there, right? Because, I guess the complete opposite of this approach would be, let's say you download from GitHub, and I've seen in previous years, people would do like, they would come here on the class code and they would just double click the digitizing partial, right? Which is not what I want you all to do. But if you do that, you're still going to have that script popped up. You're going to be on the wrong project. And this, in fact, is not the file that I want you to work with, because if you develop this script here and you save it, you're saving that on the 2024 DSA folder, which is not where I want you all to save your work, right? That is just a way for me to share with you the file that you use. So if you just click, so in this example is completely what I do not want you to do. So let me just close this and maybe show an example that would be a little bit more relatable. So let's say you come on the 05 digitizing, you have already pasted the code here. So you're seeing the code there and you just double click the code. So that is, it may already, if you already have an RStudio window open, it may open in that environment, and that environment may or may not be the correct project, right? In my case here, it just opened on a project none. And even though it's showing me here the right directory, but sometimes this doesn't work too well, right? So if you double click the script, it's going to be up to luck to see where you end up and to make sure the path is right. I don't want you to be relying on luck on this. And it's not like this is like, oh my gosh, it's such a huge deal. It's not, right? But the thing is, a lot of times you can save yourself headaches by opening the project and then launching the script from within the project, especially when it comes to reading data and exporting data. Because if you go through the project it makes sure your paths are working right. And that is one of the things that the project does for you. Okay, so Doug, did that help to understand the differences there?
Yes, but,
What are you seeing?
I moved my folder. I think I actually moved to trash.
Do you need some help or?
If I move something to trash, can I recover it?
Yeah, yeah. So if you just open the trash, it should be there. You should be able to just, drag it out of the trash and drop it wherever you want.
Well, uh, may I ask a question?
Yes.
So I mine when I went to create new projects, it was graded out, and the project was created inside code.
Okay, so
I had no.
if you did create
Go
the
ahead.
project inside code, I mean, what you can do is basically just like drag and drop out of code and have it on the same level as code, right? So instead of being inside of any of these subfolders, you want it to be at the same level. So you can just drag and drop, out of code and into the main project folder, which is 05 digitizing.
Okay.
And that's the R proj, right? So the R proj, we want it to be at this level. The only thing we want to be inside code is the actual code, which is the QMD file.
Yeah, the 0202 digitizing.
Yeah. Okay. Anyone else?
Question,
Yeah.
are we supposed to have that completed one? Cause I pulled off the GitHub just a minute ago and all that I saw was the partial, not the completed file.
Yeah. So you all should only see the partial. Yeah. I have the complete version, which is what we're gonna get to at the end of this class after we're done with this exercise. But you should all just be able to see the partial one. All right. Anyone else needs help to set up folders, files, projects? Okay, I don't hear anything, so let's keep moving. If you don't have yet the 05 digitizing project launched, please go ahead and do that. I'm gonna do that on my side right here. And again, when you pull it up, if you can always click on that rproj blue button right there. That takes you to the main folder of this project. You can navigate to code and just click on that partial script, and that's gonna pop up the script so we can start developing it. Okay, so if you have worked with field data, especially on-farm field data, you probably know that having a boundary of that field is very important for many different reasons. So what we're going to need a boundary in this class for two main reasons. One of them is going to be, we're going to retrieve some open source data that relies on having given a boundary to retrieve that data. That includes weather, soil, remote sensing. So retrieving open source data, you need to know where you are. You need to have a boundary of that field to retrieve that type of data. Also, whenever we start working with on-farm data, which we will after this exercise here, we're going to use the boundary to define our extent, right? And also that's going to help us to filter out some data that may be not correct. So having a boundary is really important. I have some collaborations with other professors, other extension specialists, where sometimes we need to pull open source data, especially remote sensing. So I work with a few growers where, they wanted, we're doing a study that we need to see how did the crop perform last season, and they don't have view monitor data to give us that information. We can bring remote sensing imagery and use that as a proxy for crop yield, and then learn something about that field with remote sensing imagery, which, Doug, is something that we're going to be working on your side project. And for that, I need to have a boundary, right? So having a boundary is really important. In previous years of this class, I provided the boundary to the students, and then I realized after getting some feedback from students that they did not know, if they don't have one, they didn't know how to create one. So I want to show you here how we do that. It's a very simple step actually, and I want to show you how to do that in R. So a lot of times, you know, because some growers may be very savvy on technology. They may already come in, have all sorts of geospatial data that they use. They may come in already have a boundary to give you. Awesome. If they don't, the easiest way that I think I can make for them to help me get a boundary is send me the coordinates of your field centroid, right? So if you go on Google Maps, on Waze, whichever phone app that is geospatial mapping app, you can go there, drop a pin, it's going to give you the coordinates. That's all that I need from them. It's easy for them. They send me that. It's easy for me to just make a drawing of the boundary looking at the field centroid. If you have already done, so digitizing is what it means is basically you drawing a boundary or dropping points or a line that may represent a river or something, whatever it is. But as you using a base map behind on the background and just making a drawing on it, that drawing becomes then a vector file that you use, right? So it's not just a drawing, but it's a drawing that it takes into account the geospatial context of that drawing, right? So that's basically what digitizing is. You know, any GIS that you come across will have that option of digitizing. So like ArcMap or QGIS, even Google Earth. You can also do this in Python. And of course, we can do that in R. That's what we're going to be doing today. So I just want to make it clear to you that, you know, probably you have done already digitizing to some extent using one of these other softwares. I do want to show you how to do that in R because it's really straightforward, as you're going to see here. So this is what we're going to be doing today. So the situation that I'm proposing for as the motivational example here is that throughout this semester, we're going to be using geospatial data from a given field that is in South Georgia. We're going to be using EO data, so electric conductivity data, what else? Elevation data, so terrain properties, a lot of different things from this single field. And let's say that, you know, this grower has all this data that they provide you with, and they're, you know, trying to answer whatever question it is, but they don't have a boundary. Of course, if you already have all this data, you could bring one of those layers, see where it sits in space, and just draw around it. My example here is more like you just ask them for the field centroid, and that's what they give, right? It's easy for them to give you that. Anyone can do this very easily on a phone app. So I just want to show you how we would go about doing that. So let's say that this grower gave you the field centroid. So this is in longitude and latitude degrees, decimal degrees here. That's what they would give you. Now let's walk through how we would use this to actually make a boundary for this field in R. I have here some packages. At least I know that at least I have not asked you to install leaflet extras or map edit yet, so I don't expect you to have those. I think you already have map view because we're already using it. So, you know, every time I give you these packages, if you want to check if you already have it, just have your cursor on the first line and just run one by one. So do not run the whole chunk, but one by one. So tidyverse is loaded, SF is loaded, map view is loading. So just finished loading. And if you do not have leaflet extras and map edit, so I do have, so when I run that, it will load it. It's not going to give me an error. On your side, if you do not have, you know, I hope that you're already creating this intuition that if you don't have a package, you need to install it. So to install it, you just copy that name. You use the function install.packages. You have to give it within quotation marks. So we just run this install.packages. Once it goes through and install it, you can just either delete that line of code or comment it off. Because remember, install packages we only do once. we do load the packages every single time we open our studio. So I'm just going to give you here a moment for you to install leaflet extras and map edits in case you don't have those installed yet. And once you install them, make sure you load them, right? Because install does not load them. So install them and then run the library function to load them in this session. Okay, if you were not able to install or you had some issues, let me know. And as I don't hear anything, I'm going to assume you were all able to install it. So let's get to the exercise. As a reminder, just make sure you run all the packages here so you do load them for this R session, as we're going to need functions from all of them. Okay, so you have a centroid. Now, the first thing that we need to do is transform those two numbers, which right now, you know, they mean longitude and latitude, but we don't have, they're not geospatial. They're not being considered geospatial yet in R. So the first thing is we need to do that. The way that we do that is I want to create this object called centroid. So you can start coding with me now. We're going to give this the assignment symbol, and we're going to create a data frame. To do that, we're going to use this function data.frame, where I want to say lon, so just LON equals 2, and then you can come back up and copy the -84 number and just paste here. You give it a comma. We're going to break code just to make it easier to read. And then we're going to create a lat column. So you say lat equals to this number that you see up here as well. And again, remember that the centroid is something the grower would give you. And then we're just bringing that, transforming that to geospatial so we can use this in space. If you go ahead and you run this, you should now see a centroid object in your environment. If you just print below, it's just a data frame with 2 columns, long lat, and then 1 row that are the coordinates that we gave it, right? So a very simple data frame, very straightforward, nothing too special here. So at this point, this object centroid is just a data frame, right? So it is, if we get the class of it, it's going to be a data frame. So it's not a geospatial object yet, and we need it to be so we can visualize in space. So what we're going to do next is add a pipe here. And if you come after this comment here on transforming DF into SF, what we're going to do immediately next here is to transform this data frame into an SF object. If you recall, SF is the package we're going to be using in R to handle geospatial vector files, which are boundaries, points, lines, things like that. Within that package, there is a function called st_s_sf. So this basically is transforming something into an SF object. And it has this argument inside of it called coords for coordinates. This argument here, we use that to specify what are the name of the columns that we have our coordinates, right? So we can come here, you use the C function. It has to be within quotation marks. The name of the columns are long, and then you get outside the quotation marks, add a comma, open and close again, quotation marks, and left. So this is what you should see on your side. And again, long and lat here is just because that's how we name the columns. If you had named the columns X and Y, then down here you would say X and Y, or whatever it was the name, right? It's just that these names inside of the C function here of the argument coords need to match the columns that have the actual coordinates. If you just run that now, and I'm just going to copy centroid and paste that below so we can print it. Now notice that this is not a data frame anymore. It is a simple feature collection with one feature, which is just one centroid. And it is of geometry type point, right? So notice how if you give 2 coordinates, yes.
I'm going to introduce this. No applicable method for the SDA apply to an object with class Sure.
Okay, so based on what it's saying, I'm guessing you probably had something wrong here. So this piece of the code is creating a data frame. It seems like maybe you created a character string.
I see no difference. My pipe was typing wrong.
Okay. Yeah, okay, nice, nice. Yeah, so it's just a pipe error there. Okay, so if if you run this now and you print it, we're just inspecting that. So it is a simple feature collection. So it is an SF object. It is a geometry of type point. So if you give a coordinate and you ask to create a SF object, by default is gonna assume it's a point. I think it makes sense, right? Because there's no way you can give a point in space and ask for it to create a boundary for you. That makes no sense, right? Because a boundary would have multiple points that are connected, right? So it makes sense that's assuming this is a point. It gives you the bounding box of this, which I guess for a point is not really important. But something to notice here is the CRS is NA. And that's because we just gave it numbers, right? And even though we're calling those columns long lats, which for us humans, it makes us understand that this is WGS84, but the computer doesn't know it, right? So we have to tell it what is the original CRS that this was called, that these coordinates are representing. That's what we're going to do in the next step here. So if you add a pipe, just come after the comment so you keep that structure for when you're reading the code as well. There's this other function from the package SF that's called st set CRS. So we are setting the CRS, right? I think we talked about this on the CRS lecture, but I just want to refresh this in your head. You know, the grower in this case gave you these coordinates in WGS84 because that's the most common one that a lot of different GPS and enabled devices use. So we know that this is WGS84. If I come here and I give the CRS of, let's say, UTM, that is in meters, I'm going to screw this up because it's not going to be in the right place, right? It's not using the same CRS. So whenever we are setting the CRS, this is not what you want this to be. This is what it is when the data was collected, right? So WGS84 is the case for that. So here on the st set CRS, it has an argument called value. And this is where we give the EPSG code of that CRS. This may be a long shot. I don't always remember this number, but does anyone remember the EPSG for WGS84? Yeah, you got it. Yeah, 4326. Yeah, so the EPSG code for WGS84 is 4326. I always in my head I think like 4632 or something like that. So I always just Google EPSG WGS84 if I don't remember, but that's good memory, Vijay. So if you just run this and now you print that centroid, now we do have a geodetic CRS being set to WGS84. So now it is a geospatial object and it knows where it should be in space because now it has a CRS attached to it. Sometimes when we import, let's say, shapefiles, shapefiles are made up of a lot of other accompanying files. It's not just the SHP. And one of those accompanying files is the .prj file. And that file, if it comes with all the accompanying files of that specific shapefile, is the file that carries the information of the CRS. So sometimes when you bring a layer that's already on your computer into R and it has that information with it, it may already come with the CRS information, so we don't have to set it. But in this case, we're creating something from scratch here, so that's why we're setting it. Okay, so
I got a question.
Yeah.
So centroid here, is that the result when we first printed long and latitude, or we just type it and print it?
So the object centroid should be the result of all this, right? So when you print it below here, it should be, so it was a data frame that we transform into SF and assign a CRS. So it should be a simple feature object of type point. with a known CRS WGS84. So this is what you
So,
wanted.
but I guess yeah, okay. So when you run all this pipe, it should create a centroid over there, not me typing it, right?
It should.
Or I can, because it didn't create in my end.
Oh, we didn't create. So you're not seeing like an object here.
I see the object there.
Okay, so when you, well, I guess on your side, you did not have this, right? I just like copied from the name and paste below here just to print it. Is that what you're asking?
Yeah, because I type it. I didn't copy and paste. I just
Oh, yeah.
type centroid.
Yeah, no, that's completely fine. Yeah, I mean, was just, yeah, if you type it, it's the same effect.
But so when I printed it, it gave me something SF 1 by 1, and then a little table say geometry.
Hmm. Did you use
Yeah.
the STSSF and ST set CRS just like I'm using here?
Yeah.
Okay, so let's try to visualize that. If you cannot visualize it, let me know, because it may just be perhaps a difference in package versioning, but I don't think, if that's the case, I don't think it would matter when we visualize it, but if it does, let me know. So in the next step here, we're going to visualize it. So if you don't see what I see, let me know, we can talk about it.
Okay. Right now, I don't.
Okay. Yeah, let's see on the next chunk here. And then if that's not the case, let me know. So on
Okay.
this next chunk here, we're just going to use this function map view, which we have already used on the previous exercise. And we're just going to call the name of this object that is centroid. So map view centroid, it should launch for you this map view map that's interactive. If you zoom out, this is the default base map that shows you is like something that is not satellite. If you come here on the stack symbol, you can change that to Esri world imagery, which is what I want you to do. And that will show you the actual satellite imagery as a base map. So the centroid of the field is right there, right? That's the layer that we brought. And the field is basically this that you're seeing here. So this is the field that we need to create a boundary for. Okay, so once you run map view, make sure you come on the stack symbol and change the base map to Esri world imagery, and that should get you to the right place. Now let me ask, was someone not able to see this? Rolando, are you seeing the same thing as I am? Okay, so whatever happened up there, I guess did not affect here.
Yeah.
We'll see head
Yeah.
later on, maybe. But right now, I'm seeing the map.
Someone in Tifton had a question?
Yeah, Clint. Which mine's doing the same thing that it did the other day. There's no
Yeah.
anything there. Which I did, like, after I talked to you, I went and downloaded our tools and I installed it, restarted everything, and I still haven't been able to get anything to pull up.
Yeah, so Clint, in your case, I don't think you're going to be able to at least correctly digitize if you cannot see the base map, and you cannot see any of them, right? Any of the options.
No, sir.
Yeah, so let's iterate one more time on what's going on your side after class, because yeah, if you cannot see the base map, then you're not going to be able to digitize, unfortunately. But let's revisit that after class. If that's okay, then we'll make sure to troubleshoot whatever's going on.
Works for me.
All right. So except for Clint, was everyone else able to, are you able to see your base map for the field? Okay, awesome. So, okay, so now we can see where the field is. Now we just have to go ahead and digitize this boundary. So that's what we're going to do next on this next chunk here. to digitize in R, it's kind of like a two-step thing where the first step is us creating or setting up the map to be digitized, which we're doing in this first or this next step here that I'm calling digitizing. So here, what I want to ask you to do is give this the assignment symbol. Let's call the map view function again. Let's give that, again, that object called centroid. I want to give a comment here, and I just want to show you. So if we were to change the default base map in code, instead of having to type that up inside of map view, or not type that up, but instead of, if we want to specify in code, instead of clicking on the stack and changing to ASRI, there is, I think we saw this already in the previous exercise, but there is a argument here that's called map.types. You just say equals to, you open and close quotation marks, and then we just type the name of that boundary right here. And it has to be exactly like this with the capitalization as well. So ASRI uppercase E dot world uppercase W imagery uppercase I. That's what we have to type here. I'm just going to do it on my side. So imagery. You can just go ahead and run this just to make sure that it's doing what we want it to do. If you had a typo on that name, it may not show you what you want, but it worked on my side. Now, for us to be able to digitize this map, we have to, this map view object has a component of it that's called map. And to assess that or access that, we need to give the add notation and say map, like that, which is basically just extracting that map from the map view object. If we do this and we print it, it's still what we were seeing before. And if you notice at this stage, we don't have any drawing tools showing up here. The next step we want to do, so after that add map, I want you to give it a pipe, hit return, and we're going to type this function add draw toolbar that comes from one of the packages that we installed today. So if you're not seeing this function populate when you start typing it, maybe you do not install properly or do not load, and the packages leave let extras. So we just add that function here. Once you run it and you, I guess, ask to print this object, now it gives us this drawing toolbar on the side that we're going to be using to draw the boundary. Okay, so what I want to do, so now we basically set up the map, but we need to do one more step here on the following chunk. So if you just scroll down here, we're going to come to the next chunk here. I want to call this boundary and give it the assignment symbol. And we're going to use a function called edit map from the map edit package that we installed today. And we're going to give it this object we created above. So digitizing is the name of the object. So when we run this is going to launch a view panel that is going to allow us to make a drawing. And I'm going to show you how we do that. Whenever we're done with that drawing of the boundary, you click done. And when you click done, it's going to close that window and it's going to bring you back to R. And whatever you drew on that map is now going to be assigned to this object that we're calling boundary. Okay, so let's do this together. If you come here in the chunk and you run this boundary line here, notice how it opened up a viewer panel on the side. What I want you to do is to pop this window up by clicking on that up arrow button there. So it kind of opens on your browser. And that's going to give you some more space to work with. If you're seeing the field like I am, I want you, so on this drawing toolbar on the left, you can draw lines, polygons, squares, circles, drop points, and things like that. I want you to click on that second icon there that is for a polygon. And then once you click on it, your cursor changes. So if you click on something, you're gonna drop a point. So now we're gonna keep adding points to make the outline of this field. I want you I mean, you don't have to be, like very, very precise, but I do want you to not include the trees. And the closer you can be to what seems to be the boundary of this field, the better. Because that's gonna create a boundary that's closest to its actual, place. So really once you added enough points that you think are good enough to represent the boundary here, and you still have your cursor available to click more. Once you're happy with your delineation, you can come here and just click the first point that you dropped, wherever that was, and that's gonna close this shape. Once you do that, you see that if I keep clicking now, I'm not adding any more points. So that's how you know that you were done. And you're done again when you click the first point that you created. Let me do that again on my side. So if I just close this window here without clicking done, then nothing was saved. I'm just gonna do that because I want to redo this step. So to redo this step, I would come back here on this chunk, the boundary chunk, run that edit map again, pop up the window again. I zoom out a little bit just so I can see the whole field. I click on that polygon button on the left-hand side, and I just start digitizing. I started on the top. You don't have to start there. You can start anywhere. But I just started there, and I was just clicking and dropping points to make the shape of this field, to digitize this field. Oops. I guess I need to delete the last points. Yeah. So if you drop a point in the wrong place, let's say I'm going to drop one in the middle here. Let's say I click my mouse by mistake and you don't want this, you can come here and click delete last point and it does that for you. But anyway, so once you're done, the last point you click is the first one that closes the shape. And once you're done, I want you to click on the done button. If you just close the window, it may not save this for you. So I want you to click on that done button, and that changes, or that closes that viewer panel for you. Then go back to R. Now, basically, it created this live session for you to interact with. And now whatever you drew on that map is assigned to this object that we call boundary. So if we just print it, so I do not click again on the boundary edit map. I'm just printing boundary after going through the digitizing exercise. Now I see that it has a few different components, and you can see by looking at the $sign. So it has a drawn component, it has an edited, a deleted, a finished, and lastly, an all component. Each one of these here may be a separate SF object. The one that we are interested in of all these components is the finished. Before we move on, I just want to make sure and want to ask, was everyone able to draw it, to click on done? That window closes, it comes back to R. If you print just the boundary, you see you see something similar to what I'm seeing here.
No, I'm not seeing that.
You're not seeing that?
No, I'm seeing a table of 1 into 3.
Okay, you're not seeing, so wait, what are you all seeing? What was your?
A table,
There is one SF and there is R console. And if you click on that, you will see like this. But there are also like other options.
Let me come and see which one I was seeing, because it may be what you're all seeing.
When I run it, it comes like this.
Okay.
I think it's.
Okay. Gotcha. All right, so I think maybe my version of SF may be different from yours. Maybe mine is outdated. I should probably work on that. But if you, what you may be seeing on your side is multiple little windows here, where each one of
Yeah.
them is showing. I mean, each
R
one of them,
console, SF, and SF.
sorry, can you say that again, Kumar?
One is R console, one is SF, and another box is SF.
Okay, yeah, I think it's just a different way of printing, but still the same content. So if you click on the other ones, on the other windows that pop up here on top, you should see this content in the second or third window, perhaps. It's just printing differently, but it's still the same thing there. So if that's the case, I think you all got it right. It was just not, it's not just not printing the same way that it is for me. But that's okay. That should not affect it. Okay, let me come take a look. Just saying, so what happens if you click on the first, I didn't have one, this one? It pops up like that? Okay, let's just make it like a quick test here. So if you click on that, on the arrow there, on this one, the one, to open that in your browser, and then you zoom out. So then click on the polygon, and then you just, you can run there, just to make sure that it's going all right. Now if you go back, let's just print the boundary. See if that, yeah,
that's one. I did it in this window and just close that window instead of going to my browser.
yeah,
Something like that.
yeah. And also, if you just close the window even on the browser, instead of clicking done, it's not gonna save, right? So when you click done, that's when it saves. Okay, so let's try this next step here, and then let's see. Yes. Okay, hold on. So it's just saying they're gonna find function pipe. I think you have to go back to the setup chunk and reload the packages.
Oh,
Because the pipe comes from tidyverse. That must be it.
so, yeah. So, it always done package.
I mean, yeah, it seems like it's working now.
Yeah, but every time I have to install that.
Oh, really? Every time? Okay, let's look into that, after class. So we are getting to the hour here. Okay, so it seems like, I mean, we're able to troubleshoot for some students here in Athens. Now this is an important step that I don't want to rush. And so I just wanna, I think Neva, you're gonna be able to get to that. Your issue is it seems like it's with map view that is not working on different days. We're gonna get to that, on one by one. Online, was anyone not able to, well, let's do this. Let's just make a test here. If you come on the same chunk here that you just created this boundary, let's just type map view and then boundary, because if it worked for you, you're gonna be able to see that boundary. Oh, sorry, we need to give the finished here. So map view boundary $ finished. You should be able to see the boundary. If you were able to successfully digitize, you should be able to see it correctly in space. So I guess maybe we can wrap up today by saying if you do map view boundary $sign finished, then
Yes.
we're successful. And we're gonna keep
Yeah.
doing next class. If you are not able to see your finished correctly in space, let me know and we can work on one-on-one and I can help you to be ready for next class. Yes, Kumar,
Yeah, I'm able to see that.
you are able?
Yeah.
Okay, awesome.
But it is just the outline. There is no background in there.
Yeah, you can come and change that if you click on the stack symbol and just choose a different
Okay.
one.
Yeah, I can see that.
Okay, was someone else online not able to do this?
Okay, I'll say mine, so Clint and Tipton,
Mhm.
mine here, like in R, it isn't pulling up the background imagery. But whenever the previous step, when it went over like to the view tab,
Mhm.
I could see the background then, and I could pull it up like actually be able to outline the field. It's just back in R, there's no background imagery.
Okay, so I guess that's kind of the workaround then, because we really want to pop it up on their browser to do the digitizing. So if that's working, then that's what matters. And then when it comes back here, you know, I mean, it's important to see, but it's not like you cannot do it if it's not showing in the R console or the R script. Still, we want to try to troubleshoot that for other exercises. We're going to be using MapView a lot. So I still want to try to help you to fix that, but at least you were able to do the digitizing, correct?
Yes, sir.
Okay, awesome. All right, so let's wrap up here for today. So next class, we're basically going to redo this. I do encourage you that if you want to play around with digitizing a little bit more to get familiar with it, you can do that. Right now, we have not exported this boundary yet. It just lives as a boundary object that we created. We're not exported to file yet, which we're going to do at the end of the script. So next class, we should be able to finish this script here. We just have a few more chunks to go through. And then I want to show you how to pull some open source data like elevation for a field, which I think is really useful, both if you're working on a farm or for a grower, but also if you're doing research, because as you may be aware, if for a grower, elevations may be helpful to explain some yield variability on that field. If you're doing research, you can look at elevation gradients of your sites, and that may help you to decide where to put your blocks if you may need blocks for that study. So the next step is going to be applicable to everyone, I hope, either in one way or the other. And so that's what we're going to do on Monday. For now, let me just go ahead and launch and create an issue for attendance. So you can claim your attendance, and then we'll keep things going next Monday. All right, make sure you claim your attendance, and then that's all for today. If you did have issues with digitizing or package installation, whatever that was, send me an email and I'll help you via Zoom. All right, thanks everyone. See you next week.
Professor, quick question. Did you get my